Okay, these videos ran a lot longer than I anticipated. They're a total of about 3.5 hours. The video on this first problem, which is the 101 problem on version 4 of the sample problems that I set up. Took about an hour and a half. Now I'm going to go over it briefly. You don't understand any of these details, you're going to need to look into that hour and a half movie. Okay, now I'm going to go through things in about the same order I did in the hour and a half. See, shouldn't be too hard to find what you're looking for. But first we take a 4x4 rectangle and subdivide it for the toolkit reciprocal function. And there it is. Okay, and I've constructed the toolkit reciprocal function after labeling all the construction lines, and I need to see that labeling. You've got to get full credit on this thing. That'd be a substantial penalty if you don't label those things. Okay, so you need to do that. You need to do all these details that I'm going to mention. Okay, now I did this. I did the whole thing step by step, and I think I did it pretty correctly. A couple little glitches, but right there's your curve. You have to know. You start out on the left edge, the construction line below the middle, and you have to know where that construction line is. You have to be able to label it correctly. And you go one right to one down, one right, one down, and you're done on that side. And then similar up here, the line just to the right of middle at the top boundary, one over, one down, one over, one down, one. You connect your curve and you get your curve. Now, I'm not going to tell you how I calculated these. If you want to see it, look at the first part of the video, see how this whole thing's been set up. Now, at the first setup, we don't have any of the common lines, just have the labeled construction lines. Then we get into answering some of the questions. Now, hopefully you've read the problem and made an attempt to do this. So that will save you a lot of time if you pretty much did it right, if you recognize what you see here. Let's be sure we understand what all we need. Okay, now I think one of the first things I asked you to do is estimate the solution of g of x equals, and I forget which one it is. It's not that one, it's not that one. I guess it was g of x equals negative 13.3. So there's a line where y equals negative 13.3. G of x, your function, would of course stand for the y value. G of x is a y value. So we have this point when we project that down, and that's the point x equals 15.25. So that's what these yellow lines might represent. I don't remember if you're given x equals 15.25, y equals negative 13.3. I think maybe it was a negative 13.3. Okay, and then you're given x equals 14.7. There's your purple line for x equals 14.7. It's the curve there. You estimate your y, you get negative 12.8. That turns out most of these estimates were accurate to within plus or minus 1/10. So that kind of surprised me. It's a kind of a small graph. You want to draw a bigger one, you'll get better estimates. You'll build more confidence. Okay, so anyhow, those are the lines that we use to make those estimates. X equals 14.7, hits the graph there. Y equals negative 12.8. On the interval 17.1, 17.5, we're asked to estimate the rate of change, the average rate of change. Well, we just estimate when X is 17.1, we're on this line and it hits the curve there. And we estimate now that Y is about negative 11.1 at this point. They have to be able to read the scale, you have to be able to understand the numbers. Look at the video, I do a lot more explanations. It's real video. Okay, X is 17.5. Well, there's your line for X equals 17.5. It's a graph about here. And we estimate negative 11.3. Now I think those estimates hold up pretty well. And I think the rate of change that we get holds up pretty well. Okay, now let's back up a minute. I also asked you to make a table for the showing the construction points, the x's here. Okay, well, there's the table. That's obvious. You should be able to find that very easily. And then here we use the f of x minus h plus k form of the function. It's the reciprocal functions is one over x. So f of x minus h is one over x minus h. And h is, of course, the x coordinate of the red dot. Okay. X equals 16. So x minus h is x minus 16. You take x equals 1 over x. You replace x with x minus h or x minus 16. You get 1 over x minus 16. H f of x minus h. And then k is minus 12. And we use then this formula to calculate the y values for all these x values. And by doggone, and I expect you to do the calculation. We want to let's get in these calculations. I want to see the details of the calculation because I want to know that you know how to do this arithmetic. You're going to have to be able to do algebra very shortly. Okay. I want to see all the arithmetic when you do the calculations. But the calculations match the construction points. Now don't try to bypass this by doing all the calculations and tell me those are construction points. Then when I look at the construction points, they don't match at all. Okay. If you don't have all the labeling of your construction lines and everything, I won't be able to tell if you calculated these values or if you actually constructed them. And vice versa, I won't be able to tell if you actually calculated these values or used what you got from the construction lines, because you're probably going to get the construction lines right if you have practiced this. Okay, so you got to show me the calculations here. I got to see the construction lines. I got to see something like this without all the colors. If you need to do two separate graphs, that's take long to construct them in order to label everything. But it's pretty well feasible to do this. I want all the X lines and all the Y lines, including the construction lines and the lines you use to locate these 4 points labeled. And you see that they're labeled. You can see the labels. This one's X equals 14.7. Here's X equals 15.25. Here's Y equals negative 11.3. Here's Y equals negative 11.1. And X equals 17.1. X equals 17.5. They're all there. They're all need to be. Okay, so you need that. Now, we verify that g of x equals 13.3 when x equals 14.5. Actually, that's our estimate, okay? And then we can verify the estimate by plugging in the formula. Average rate of change here. We need the values at these two x values. We got them here. So we have 2 points. Now the 2 points we have are 17.1, negative 11.1. So I've kind of enlarged this fundamental triangle here, put it over here, 17, negative 11.1 here, 17.5, negative 11.3 here. I've done the run, I've done the rise in detail. I want to see the details. Okay. And then I know that the run is change in x, the rises are change in y, and the average rate of change is delta y over delta x. We say the average rate of change is single delta y over x, which is about negative 0.2 over 0.4. After we figured out 0.4 for the run and negative 0.2 for the rise, we divide it, we get negative 0.15. And this coincides, of course, with rise over run equals delta y over delta x. Delta y over delta x is your average rate of change, but it's also your rise divided by your rise, so it's a slope. Okay, and short comment: average slope represents the average rate of change. Not required to point all this out. The circle thing doesn't have to be there, but if it is, it might give you a little bit of slack on some error you might have made. Okay, so it doesn't hurt to write it down. Now to get the f of x minus h plus k, I did it over there, but here we've got it. I think you can still see it. Toolkit function 1 over x. The graph function is f of x minus h plus k, where hk is a coordinate, are the coordinates of the red dot. Coordinates of the red dot, I told you at the beginning, there are x equals 16, which is why the x equals 16 line goes through the red dot, and y equals negative 12, which is why the y equals negative 12 line goes through the red dot. So, f of x minus h, of course, is 1 over x minus h. F of x equals 1 over x. If you replace x by x minus h, you have to replace this x by x minus h, this is what you've got. And thus g of x is f of x minus h plus k. In this case, h is 16, so we have x minus 16. K is 12, so we have plus a negative 12. And of course, then when we compare the function in the table of the function using our x, the x values of our construction lines, we get these y values. Here's an example cost calculated. Very simple, but if you need to see it in detail, look at the longer video. Okay. Now that's pretty much a summary of an 1.5-hour video. See that there's a lot of detail in that video, and if you need the detail, you ought to take a look at that video. I also make a lot of comments that are kind of worth paying attention to. You try looking at the transcript, but waiting through the transcript and everything could be even more noxious than watching the whole video. But okay, if you're insecure in this, if you haven't put this together, this is the main thing I want you to put together in this test. There'll be 2 problems in this matrix. And they're going to, together, they'll be worth at least half your grade. So you want to be able to do this. The 102 and 103 functions are one of them that I think it's the exponential function and the squaring function. It might be in the opposite direction. So you should be able to do all this as stated there now with the exponential and squaring function. You should be able to do it pretty quickly. You don't want to be in there all day. Okay, you have limited times to practice these until you can do them pretty quickly. There it is. And I think that's all there is on this. So went into a whole 1.5 hour detail on this if you need it, and some of you probably didn't. You want to master this. It's achievable. This is something that you can get perfect on. Okay. These are very predictable. You can perfectly construct these functions just with practice. And you can perfectly make these estimates and compare them to your f of x minus h plus k function. Okay, I'm not sure. I thought I stopped the recording, but I'm not sure if it stopped and had a prompt there. Do you really want to stop? I don't know if it was recorded during that or not. Still, I located this, and this is a little more detail on making these estimates. X equals 14.7 and y equals g for 14.7. That's a calculation of what we ought to get if x is 14.7. Okay. I'm sorry. I think we were given 13. I don't remember. Okay, but here we're verifying that g of 14.7 is pretty close to negative 12.8. Now here we got negative 12.8. We calculated it here. We got negative 12.77. You probably use your calculator to do the reciprocal 1.3. And that would be fine. Not your calculator, but the test calculator. So when we say compare with the estimate, 14.7 g of 14.7 is approximately 14.7, negative 12.77. Our estimate was 14.7, negative 12.8. This is more accurate than this. Going, this was on a hand-drawn graph. We got really close just by labeling all construction lines and attending a little bit of detail. You might not get that close, but if you're in the reasonable ballpark and show me the construction lines you're using, depending on how far off you are, probably won't. That way, if it's way off, I'm going to have to say something about it. Also, we were given 13.33. We estimated y was 13.33. We estimated x equals 15.25. Okay. We found that g of 15.25 is 13.33, which is very close to the 13.3 we had. You were given this, asked to find this. Now we're verifying that this gives you something very, very close to what we were trying to find. All right. look at the full car and a half video if you need one. And, you know, you want to see this, you can kind of read what I'm doing here. But you want to see the explanation. Make sure you understand everything that's being asked with on this part for the video. Won't be hard to find. Just gonna click through the video, you can see what I've done, what's being done, and pretty quickly locate what you're looking for.